Hey there, Mr. Jenkins. We are going to talk more about linear equations today on lesson 2.4. Just some of the various different types or forms of the equation of a line. Last lesson we talked about slope-intercept form, y equals mx plus b. That's the most basic one that you hit a lot in Algebra 1. There are also point, slope, and standard form that we're going to go over today, and then a little bit about some perpendicular and parallel stuff. All right, so I don't know that we'll need the calculator today, but I have it pulled up just in case we do. We definitely will in 2.5, so I really pulled it up there so that I would remember to tell you guys that starting in 2.5, we're really going to start using this graphic calculator a lot. You're going to start to see it in the notes. You can make Desmos work for what we're going to do in this chapter, but I really highly suggest you get the calculator because it'll last you all the way through college, so it's a good investment. With all that said, let's go ahead and get to it. So your learning target for this lesson is I can use point-slope form to develop the equation of a line and to develop the graph of a line. I should add stuff about perpendicular and parallel because that's going to be big, that's going to be tested. So anyways, just know that that's important as well. So without further ado, let's go ahead and get to it. It says in order to graph an equation, you need to either know blank on the line, so that would be 2 points, or you need to know a point, or 1 point, and the slope. So if you know, yeah, those are the two things that we would need, two scenarios. There we go. Sorry about that. So example 1 says write the equation of the line, and then it gives us some scenarios. Up above, the key concept. This is going to be important. This is not an easy one to remember. This might be a good thing to write down on your own. But the point-slope form of a line is that guy right there. Y minus y1 equals m times x minus x1. So I guess it is important to know that we sub in for x1 and y1, y and x. We also sub in for m, and then this y and this x are fixed kind of variables. This is your input variable. This is your output variable. So here goes. So if we're given point and the slope, hence the name point-slope form, let's go ahead and try to sub in. So for the first one, I'm going to just rewrite the given formula. So we can see where everything goes. So obviously slope, we call that m. So that goes right there. This goes in for x1, your x value. And then this goes in for y1. Okay, so we get y minus -1. So minus negative is plus. Y plus 1 equals -3 parentheses. And then you have x minus 7. Another thing you have to be careful of with this formula is that, we think -1 usually shows up as -1 in a formula. +7 usually shows up as +7. So this formula is kind of counterintuitive that way because the minuses are built into the given formula. Okay. So I will let you guys do 1B on your own. A little bit tougher. Or there's just one extra step if you're only given 2 points. In other words, they don't explicitly tell us what the slope is, but we know how to find the slope, right? So there's just one extra step of using the slope formula, which we talked about last lesson. So slope of this line is going to be 7 minus 0. over 0 minus -5. So minus negative, I'm just going to make that a plus sign. So we have 7 over 5. So that's my slope. So now the question is, which point do I use? And the answer is either, okay? Another place where this gets a little bit confusing is, if I pick this point and you pick that point, our equations are going to look slightly different, okay? So just kind of know that going in. That being said, I guess I'll just use the first one. I'm going to use that point -5, 0 as my point and my point slope. I already have my slope, so I am good to go. So we have y minus y1 is 0 equals m, which is 7 over 5, times x minus -5, so x plus 5. I'm not sure if Math Excel wants it as y. I think they do want y minus 0. If not, they might want you to not write the -0. So you could also say y equals 7/5 x. Sorry, 7/5 times the quantity x plus 5. So not sure how they want that on there. I think I would accept it either way. So then, before we go on to the next page, I did want to kind of, I guess, do a quick follow-up. I'm going to leave 2B for you all to do. So just kind of quickly, if I were to use the other point, I'm going to just show you something real quick. I'd have y minus 7 equals 7/5 times the quantity x minus 0. So you can see how these two equations don't exactly look alike, but if we, here's how you can kind of tell if you, this is a good thing to know how to do anyway. If we solve for y or write it in slope-intercept form, they should produce the exact same equation. So like on this one, if I wanted slope-intercept form, I would distribute, and that would give me y minus 7 equals 7/5 x, and then move over the -7, so y equals 7/5 x plus 7. Okay, over here, all I have left to do is distribute, so that would be y equals 7/5 x plus 7/5 times 5, so that'd be plus 7. So you can see they go to the exact same equation. That's how we can tell they're equivalent. So just to be clear, the answer to this question is either this or this, but I wanted to follow up a little bit about how those equations can look a little bit different depending on what point you pick. Always one of the tough things about teaching this lesson. Okay, so now graphing using intercepts. So now we're going to be talking more about, this is called standard form when we get into example B. Sorry, my board's going a little slow. So standard form of a line is ax plus by equals c. Okay, so if you ever see one set up that way, you want to think about the intercepts. It says a quick and easy way to find 2 points on a line that you can graph is to find the x and the y intercept. And that's only if it's kind of set up a certain way. So to find the x-intercept, we want to set y equal to 0, and then solve for x, and then vice versa. To find the y-intercept, we set x equals 0, and then we can solve for y. Okay, so an example in example 4 here. So when we want to, like I said, when we want to find the x-intercept, we technically are plugging 0 in for y. Hopefully that'll pop up here in a second. So it would look like this: 2x minus 4 times 0 equals 8. All right, so really you don't need to write all that out because every time you multiply by 0, it basically just disappears this term, right? So your thought is just it's 2x equals 8, and then we get x equals 4, okay? So that is the point on the graph, 4, 0. So that's one point on my line. And then the other one, this time I'm technically plugging in 0 right there, but that I already know it's going to give me negative 4y equals 8. That's how kind of quick and easy this is. And y equals negative 2. So it also passes through the point 0, negative 2. Just remember the x-intercept goes on the x-axis and the y-intercept goes on the y-axis. And if we have 2 points, that is enough to go ahead and draw our line. If we want to be real accurate, you could figure out my slope is up 2 over 4, so that's the same as up 1 over 2. So if you want to kind of put one in the middle, that's fine. You don't necessarily have to, but you guys get to use Math Excel. So anyways, that's what that would look like. If you get confused, you can always solve for y, and you should end up with the same line. Okay, so the last thing we're going to talk about are parallel and perpendicular lines. So it says many times you will be asked to graph or to find the equation of a line that is parallel or perpendicular to another line. In order to do this, you must know the slope of the given line and understand the difference between parallel and perpendicular. Okay, so parallel lines, let's see, this is just, okay, so this is kind of graphically, oh no, it does tell us, okay. So for parallel lines, it has the same slope, okay, so same M, different B. For perpendicular lines, we have the opposite reciprocal slope. Hopefully that'll pop up there. Opposite reciprocal slope. All right, so let's go ahead and maybe look at an example. So looking at 6A, and we'll probably do 6B and let you all do the other two. Well, I guess there are another two. So I'll do both of these and we'll call it a day. So what's the line parallel to 4x plus 2y equals 7? First of all, you might look at this and think, I want to find the x and y intercept, but then is that really going to help us? The answer here is no, because you need to know the slope. So given this type of equation, how can I figure out the slope? The easiest way algebraically is just to solve for y, get it into slope-intercept form. So that's what I'm going to do first. So moving the 4x over gives me 2y equals negative 4x plus 7. And then divide everything by 2 gives me y equals negative 2x plus 7 halves, or 3.5. Okay, really all I care about is this. I don't really care about the y-intercept for what we need to do. All right, so remember it's parallel. Parallel. So we have same M. I think I wrote that all. So same M, and then it also tells us what it passes through. So I know my slope is negative 2, and I know it goes through for negative 2. So if you know a point and you know the slope, then your thought is you want to use probably point slope. All right, so point slope would look like y minus y1 is 4 equals m, so same slope, so negative 2, Make sure I don't write over what I just wrote. Sorry, bear with me here. We're almost to the end anyways. So y minus 4 equals m, so we have same slope, so negative 2 times the quantity, x minus negative 2, so that ends up looking like just plus 2. All right, so we could be done if it just said write the equation, but it does say write in slope-intercept form, okay? So I have one more step of solving for y, all right? So that means distribute. So we get negative 2x minus 4 on the right side when I distribute, and then I want to just move over the minus 4. So plus 4 to both sides gives me y equals negative 2x plus 0. So I'm just going to leave it as, let's see, I did something wrong there. Oh, sorry. I plugged in, this is what I did. So hopefully you caught this before I did, but I subbed in the x for the y1, I subbed in the y for x1. So I was looking at my notes. That's the only reason I caught that. So hopefully you take from this. It's easy to make a mistake. I got the totally wrong answer. So sorry about that. Sorry to delay your video. But let's fix our substitutions. Like I said, hopefully you're watching the video like, Mr. Jenkins, what are you doing? But anyways, so let's sub in the right places. So y minus y1, so that'd be y minus negative 2 or y plus 2. So minus negative looks like plus. So y plus 2 equals negative 2 parentheses x minus x1, so x minus 4. All right, let's try that again. So when we distribute this time, we get y plus 2 equals negative 2x plus 8. Negative 2 times negative 4 is plus 8. Then we want to subtract 2 from both sides to move that term over, so we get y equals negative 2x plus 6. Okay, and then our last problem is going to be this guy right here. So this time, this is a perpendicular one, so our slope is opposite reciprocal. So same step first, though, we got to find slope, so I'm going to solve for y. Just so I have a little more room, I'm going to kind of work this way. So moving the x term over is going to give me negative 3y equals negative 2x plus 3. And then when that pops up, I'm going to divide everything by the coefficient of y, which is negative 3. So that's going to give me y equals positive 2 over 3x minus 1. All right, so really all we care about there is the slope, right? So if the slope of that line is 2/3, the slope of its perpendicular line is the opposite reciprocal of that. So opposite of positive is negative, and then the reciprocal of 2/3 is, hopefully I'm putting this in the right place, 3 over 2. I'll fix that if it's, all right, there you go. So that's the slope of our line, and then at this point, we want to write in slope-intercept form. So if I'm just not thinking here and I just plug in, then I'd do y minus 6 equals m times the quantity 3/2 times, equals negative 3/2 times the quantity x minus 0. But there's a shortcut here, right? Any ordered pair in this form is b, right? So if I notice there, I can save myself a little bit of work, right? So this tells me that b equals 6. So I don't really need to do those extra steps. So my final answer is y equals negative 3/2 x plus 6. See how that looks when it pops up. All right, very good. All right, so that is it. If you want to stick around just to kind of see what you can, just to kind of see how you could do a visual check if you had a graphing calculator, that's fine. This stuff at the bottom is something that we are skipping. It's about piecewise functions, and they teach that in pre-calc from the ground up. In other words, you don't really need to see it yet. So just ignore that part of the notes. So like I said, you can go ahead and sign off and get to work. But if you want to stick around, I'm going to show you one more thing in the graphing calculator. All right, so I'm going to go ahead and look and see if these appear to be, if these two lines appear to be actually perpendicular, if they cross like a T, if they cross at a 90-degree angle. So I'm going to go ahead and use my graphing function. So go into y equals, and then I'm going to type 2/3 x minus 1. So 2/3, I'm going to do like that, and then times x. So that's your input variable button right there, and then minus 1, and then I'm going to type in the other one. So that line's going to be blue, and this other one's going to be red. So the other one was -3/2 x plus 6. -3/2 times x plus 6. And then let's go ahead and look at the graph and see if they really are perpendicular. Okay, so it doesn't actually look like they are, but I can tell you that they are. I don't know. It's just something with the display, I guess, where they don't exactly look perpendicular. I don't know if my window's kind of messed up or what. I'll try to figure out why. Yeah, I'm not sure why it doesn't exactly look perpendicular, but you can tell that, it's at least close. So anyways, I thought that would go better than it did, but that is the correct answer. I don't know why it doesn't look actually perpendicular on there, but if we actually graphed it out by hand, it would. So anyways, the graphing calculator will be helpful in the next lesson. You can do without it in this one. So sorry for the lengthy video, but a little more going on here. So thank you for your time, and let me know if y'all have any questions while you're working.